Hello, good morning. Okay, is everything seem okay? Can you hear me? Do you see the desktop? Is everything seem set up right? Can you hear me? Is everything seem all right? Because I'm
Yeah,
not sure.
yeah, we can see
Yes.
everything.
Okay, great, thank you. All right. So, okay, now let's see. First thing is, I want to. I need to put a reminder up here at the top. But the exam is a week from today. Okay, the exam is on May 6th. So a week from today is the final exam for the class, and I'll put that link up here at the top. I forgot to move a copy of it up to the top just so you could see it real, more prominently. Okay, so if we have time, well, today one of the things we can do is we'll go over some of these problems. But first, let me ask you if there's any questions about the current homework assignment. Okay, so there's this homework assignment that was due this week. Okay, so did anybody have any questions about the programming assignment? I'm just opening it up in the meantime. Does anybody have any question they want to ask about this assignment?
I did have a question.
Sure.
So for like for the assignment, is it okay for us to read like the numbers from a text file?
Well, you have to read them from a text file, but you're supposed to do that using standard in, using system.in.
Okay.
So like we showed in class the other day, you should do it so that you could. The program's not supposed to know that it's reading from a text file. That's done for you in this here. Remember, this is what makes it read from a text file. The program doesn't know that. Okay, so the program is supposed to read from standard in, from system.in.
Okay.
So don't use any function calls that open a file, for example. There are functions there are methods in Java that will open a file. You're supposed to just use this. Dr. Java didn't open up properly.
Okay.
Okay.
I think I understand now.
Yeah. And yeah, but have you been able to get that to work? Have you been able to get system.in to read your file?
No, I haven't.
What goes wrong?
Um, I think it just might be what I'm like typing into the command prompt because I don't know, it got to the point where I just kind of like gave up on it and just started reading from a text file on my computer.
But you won't get any credit because that's not what the assignment asked for. So
Yeah.
yeah, and this is actually from the point of view of Java, you don't do anything. And did you double click on this test file, this thing here?
Like run the test script
Yeah,
or
double
like
click on.
yeah.
What happened when you double click on it?
It run or yeah, I got that same error there.
That means you didn't compile your program. You can't run the script until you compiled your program. See, this program hasn't been compiled, so there's nothing to run there. Okay, remember, yeah, I can make it run. Do it again. Int x equals in dot get int for next int system dot out dot print line x. Okay, so my program wants to read something and print something. Okay, I'm going to delete this part here. I don't need it. Okay, make sure it works. Compiled. I can run it here. It asks me for a number. and it prints out that number, okay? Now, if I go over here, I can double click on this run test script. Okay, see, no error. Okay, and if I look in the output, one number is in the output. It read one number from the test data, 81, and sent it to the output. See, I didn't have to do anything in my Java program, didn't do any, it just read from the scanner and printed the standard out. And then I double clicked on that file and it did what it's supposed to do. It read from the test data and it sent the output to the test output, to the test script output file. So it read from here and wrote to here. Okay. Now notice that in the folder now is this class file because I compiled this one. So now I have this one in there. That's why I don't have that error message anymore over here. If I delete that, still the same program, it's still the same Java program, but if I run the test script, see, I get that error message. Java language class not found. See, the class file's not there anymore. Okay, and if I go back to Dr. Java, I can use Dr. Java to put the class file back there. Now the class file is back there. Now I can run that test script. Okay, did you try doing a little test like this?
No, I didn't. I'm gonna do that right now.
Yeah, see, I just wrote 2 lines of code. Yeah, I only had to do 2 lines of code to get the test to work. Read one number, print it out. Okay, that will read the first number from the test data file and send it to the output file. Okay. Okay. Now you lose the correct. Well, yeah, you'll read one number from here, and this is you're supposed to get this output eventually. Okay, but now I have a test case that reads one number from here and sends that one number to the output. Okay, and I could put if I go back to my Java program, I can print more output. Well, actually, let me do it again. X equal in dot next int. That reads one more number from the file, okay, and print it again. So this will now end up reading 2 numbers, okay. If I compile it and go over here and double click on here, it ran. And if I check the output file, see, it's got 2 numbers in it now. Yeah. Those are the first 2 numbers from the test data. So Java, it's real straightforward to get Java to read from a file, and you don't have to do anything special. And if I run my program in Dr. Java, I can still test it here. I can run it here and see there's the first prompt, ask me for the first number. And now it asks me for the second number. Okay. And now it's done. Okay. So I can test the program in Dr. Java, or I could go over here and double click on the run test script. So I can run the program 2 ways, by double clicking here or by running it here. But when I run it here, the standard, when I run it this way, system.in is this prompt down here, and system.out is this screen down here. Okay, so now system.in is right here, and system.out is right down here also. So system.in and system.out are the interactions pane. Okay, so the Java system takes care of this for me. Dr. Java takes care of this. When I run it in Dr. Java, system.in and system.out are the interactions pane. Okay. And when I run it over here, the operating system takes care of it for me, that the system.in is the file and system.out is a different file because of this script here. The script says, run the program with that file as the input, that file as the output. And this is a tremendously important idea. This is how almost everything works in the real world. People, you know, people don't run programs sitting at things like this, like Dr. Java. Like the only people who run programs in Dr. Java are people who write programs, but people, use programs all the time. And in the real world, companies that run big data programs, the data is always in files. Okay. So the data is always in files, and this is a real common way to do it, to have a script that runs the program saying this file has the data, this file is where the output goes. Okay. Okay. So get it to work in a simple case, and then you can just start, then you can figure out how to get the rest of it to work. But just make sure that you can see it, read one number, print it, read another number, and print it. Okay. Right. Well, the other questions from the homework assignment. That's one of the goals of this assignment, is to get just to get you to get used to. It's really more a matter of getting used to this idea that you can run your program from a script. Okay. Because you don't have to do anything different. You write your program the same way as if you would run it in Dr. Java. You write your program so that it works in Dr. Java. You test your program in Dr. Java, but then you can run your program with a test script. The goal of the test script is that I can run these programs over here and build new test scripts. Like, excuse me, I can generate 1,000 numbers now. Okay, I just generated a test data file with 1,000 numbers in it. Okay, I wouldn't want to type 1,000 numbers into Dr. Java, but there's 1,000 numbers. So now I can take that file of 1,000 numbers, and I can test my program over here with 1,000 numbers. I can replace the test data that came with the program with my new test data. So I can so I can test my program all I want with more and more data. And that's that's a real important idea, that I don't want to just test my program with one set of data. I'd really like to be able to test it with more and more data. And over here is the way to generate more data. These programs will let you test it with lots of different kinds of data. And then you can compare your output to what was generated in here. You run this. See, there's 15 numbers. There's the output. You can run your program with that same data and make sure you get the exact same output. So I can keep this window here, and there's a sample of output. I can take this data file here, put it in this folder, then run my program in this folder by running that test script. And then what gets put into this file here if I open that file, it should look like what's in this window here. If I had a version to run over here, that if I ran my version, what appears in this file should look like what's over in this window. So I can check that my program works with other data. Okay. And again, getting used to manipulating things on your computer. Get used to not just working in Dr. Java, but get to realize that you could test programs outside of Dr. Java also. Okay. Well, other questions of the homework? Anybody have a question about this homework assignment?
I am back after I tried running a test on it,
Mm-hmm.
and it said it was basically the wrong. It couldn't find or load the main class HW3,
Mm-hmm.
and even though it's named the same.
Did you open the file? Did you do the work in Dr. Java?
No, I'm using my own compiler that I've used for this class before.
What compiler do you use for this class?
Eclipse.
Okay. Where is Eclipse putting the class files?
I have it putting it in that same folder.
Do you see the class file in that folder?
Yep.
Are you using packages?
For this one, it's just the default package.
What do you mean by the default package?
It's just the if I don't add a package with a name, it just creates like a default one.
So you don't have a package command at the top.
No.
Okay. Did you open this? Do you open this test script to see if it's been changed? Yeah. Does it look like that inside of it? See, it just says job.
Oh wait, hold on. Well, give me 1 second.
Sure. Okay.
Okay, I tried to. I thought I had it. And do you think it could be the package command at the top? Because I tried removing that.
Yeah, you can't have a package command.
All right.
The package command's an advanced feature of Java that we're not using. And if you put a package command in there, things don't work right.
Okay, so I removed the package command and tried to run the script, and it still is giving me
Did you
the
recompile it?
I did, yes.
So, and what error message do you get?
It's the same error message. It's the wrong name.
Wrong name?
Yeah,
It doesn't say here. It doesn't say wrong name. It says
yeah, it looks
class not found exception.
The mine is no class def found error.
That's different. Class not found exception. Read the error message exactly.
The error message is caused by java.lang.no class def found error.
Oh, I'm trying to remember what that one means. That's not this error. That's a different one. I'm trying to remember what that one means. That's not this error. Is the class file in the folder?
Yeah, in the demo folder, or the not the in the homework 3 folder that you gave us.
Open a command. Do this. Can you see what I'm doing?
Yep.
Type CMD in that address bar. Get a CMD there, like that. You know, like I just did there. You click in there and just type CMD, hit enter, and you get a prompt like this.
Okay.
Then type Java homework, well, HW3, and just type Java and then hit enter.
Yeah, no, still the same error.
You may have more than one version of Java on your computer if you're using Eclipse, and yeah, you'll have to come to office hours. You have to get the thing is, I asked for people to use this one system because for reasons like this. You may actually have more than one Java on your computer, and so if you do, things don't work properly. Now, Eclipse might have one version of Java, and there might be. Did you install the Corretto JDK at the beginning of the semester, like I asked people to?
Yes.
And then you installed Eclipse also. You
Yeah.
may have two versions of Java on your computer.
Yeah, well, I've already had Eclipse installed, so that I can try removing
Oh no! Here,
all my versions of Java.
do one last experiment. You got this command prompt open?
Yep.
Type Java C homework 3.java. Then type Java homework 3.
That the first command gave me an error.
Java C?
Yeah,
Then
missing
what?
return statement.
Then your program doesn't compile.
Oh wait, is there a? I think there's a bracket missing. It says there's a bracket missing,
Yeah, your program's not compiling.
but it doesn't tell me where. Oh, this will be fun.
Okay. Okay, we can let's go on and okay. If I'm going to go on and we can go back to this later on, or you can come to office hours and we can look at what's going on there, because you should get your computer settled down. You should get it figured out how to work with things, because if you set things up the right way, you can do a lot with things. But right now, your computer's not set up the right way, and you can't do something simple like running a program with a script file, which is important. It's important to be able to run your program with a script file. So it's a good idea to get everything set up the proper way. Okay, so what I'm going to do, okay, I'm going to close that and do something, go on to the next idea. Okay, so
Oh wait, I figured out what the issue was.
uh-huh.
I didn't get it. I was able to get it to compile because I had a loop to loop through and read all of the
Yeah,
from the
yeah.
file. And for when I was reading it from a file originally, there was a try catch statement there. So
Yeah.
it basically there was nothing that was stopping this loop. So when I just tried to compile it, my computer just started my usage of memory just started going up because there was nothing stopping that loop. So I think I figured it out.
Okay. So, okay. Well, give it a try. See if you can read you should be able to read the file from the script. You should be able to run your program from that script. Okay. All right. Now, okay. The next thing to talk about, anybody have any other question about the homework assignment? Anybody else have another question? Okay. Now, the exam's a week from today. There's these review problems about stuff we've talked about since the last exam. So these are review problems mostly about arrays and a little bit about classes. Those are the two topics we've done since the last exam. So that's these chapters here on arrays and classes. Okay. So anybody have a chance to look at these problems? Anybody have a question about any of these review problems?
Can we go over number 11?
11?
Let's see what you get.
This one here? Okay.
Yeah.
So okay. The best way, okay, let me start by putting it in a Java visualizer. So let me take this and put it in the Java visualizer.
Oh, is that so on the number 11? It seems like more things are going on at the bottom. Are they all part of the same problem, or are they different? Like, for example,
Yeah, yes, they would be like what's in the main method. Okay.
Oh,
see,
okay.
yeah. So the idea would be, here's how we would do it. There's this class, okay, and then I can put in this class a main method so that I could run it. Okay, so the idea would be, here's a main method to go with that. And now the questions are going to be, for example, suppose I have that. Okay, so that goes into the main method. Okay, there's that in the main method. Okay, now I can compile this and make sure it compiles. Whoops. Okay, see, yeah, now I can have A. Okay, so see, there's I got A and B. Okay, so there's the class. Now I create an A and a B thing, and then it asks questions about these. Okay, so it's like, okay, there's a, what's, take this. Okay, so here it says, explain why each of the following statements is either okay or not okay. Okay, now let's check this one here. Is this okay? Let's think about it first. Let's read the code. Okay, this is taking the B thing and looking at the X variable in the B thing. Okay, but the variable X is private, so you can't look at a B thing. Now the trouble, now if I take this code here, gotta be a little bit careful about this. If I put it in here, it doesn't seem like there's anything wrong with it. Okay, it doesn't look like there's anything wrong. And that's because I shouldn't have my main method in my class thing. That's not the right way to do things in Java. So this, to really test this, I'm supposed to put the main method in a different class. So I'm supposed to put the main method in a class, a public class test thing. Or we'll see, I could say the class should be problem 11. Okay, so there's a class problem 11. Put the main method in here. Now you'll see that this thing doesn't work. Now compile it. See? Oh, wait, make sure. Oh, public class. I forgot the word class there. Okay. X has private access and thing. Okay. Right. So now what this is question is, here's a class, and then here's a code that would be outside that class. So there's the class, and here's code that's outside that class. So I put the code in the class problem 11. Okay. Then in problem 11, I create the two things, A and B. So there's the A thing and the B thing. Okay. So I create the A thing and the B thing, and then I start checking these other lines of code. Okay. And if I just read this, I say, oh, that shouldn't work. That shouldn't work because X is in B, and I can see it over here. If I run, let's see, go back over here and run it. Well, I can't compile this now because X is in B, but it's got private access in B. So I see that it doesn't compile. Okay, so I have to comment that out. Okay, so X is in B, but it's private, so I can't access it like this. Okay, now look at the next line of code. Let's just first, before trying it, let's look at it. Okay, A is is a thing. Get Y is one of the methods in A. It's public, so that's so far so good. Okay, get Y returns a double, but this is an int, so this won't compile either. So if I try this one, it won't be okay because get Y returns double, and I'm trying to put a double in an int, and they don't fit together. So now I can try that line of code over here. Okay, and try visualizing it. And the compiler tells you incompatible types. Okay, from double to int. You can't take a double number and put it in an int. To do that, you have to throw away the decimal point. And that's why they say loss. You're losing information. If you tried to take a double and put it in an int, you'd have to throw away what's after the decimal point, and you don't want to lose that information, so Java won't do it. Okay, so that one's not allowed. Okay, okay. So again, you read the code. When you read the code, you have to ask yourself what everything does. A, okay, that's this thing. Get Y, is there a method get Y in an A thing? And you look up here, and yes, there is a get Y method. Okay, so that's okay. The right-hand side's okay. Now, the get Y method returns a double, okay, but I can't put a double in an int. So that's where I realized that this thing can't work. Okay, try this one here. So go now to the next line. So the first two lines are not okay. Now try this one. Oh, let's think about it first before trying it. Okay, we've got a B thing. Okay, there's the B thing. It's defined. Is there a get X method? Yes, there's a get X method. The get X method returns an int, but this is a double. But doubles can hold integers. So this is okay, because an integer doesn't have a decimal point. So when you take an integer and put in a double, you just get 0.0. So you just get an automatic 0.0 added to it. So this should be okay. And it compiles, yeah, and it'll run. We have to build the 2A. We have to build the A thing, build the B thing. See, we built the A thing and we built the B thing. See, they have the X, each one has an X and a Y in it. Okay. And now I can get the X out of the B thing. And put it in V. Okay. So the X in the B thing is 0, and it got copied into V as 0.0 because it read an int out of here and put the int in a double. So the int became 0.0, but it worked. That was okay. Okay. Now go to the next line. Okay. What about this one? So let me tell you, is this going to be okay or not? What do we have to check?
You have to check if it's an int or a double, right?
Well, that's getting ahead of the game. First, is there an A thing?
A thing.
Yeah, A thing is here. Okay, what about set X? Is there a set X in A thing? Is there a method called set X in A?
Yeah.
Yeah, it's right there. We can see the definition. Okay, but what does it take as input?
Int digit.
And what's this?
Double, right?
Does a double fit in an integer?
No.
No, because you have to throw away the decimal point. So that's not going to be liked. So this one doesn't work. Let's check it. Let's go over here and try that one. Okay. Ask to visualize it. And the compiler says, again, that lossy conversion. So that line wasn't good because this is a double and you're trying to shoehorn a double into a int here and it won't fit. Okay. So that one didn't work. Okay. Now do the next one. Okay, this one didn't work, so I should comment it out. So I'll comment out the ones that don't work and leave the ones in that do work. Okay, B, there's this guy here. There's B, so that's good. Is there a get Y?
Yeah.
Yeah, there's a get Y. Okay, it doesn't need a parameter. It returns a double, but this thing doesn't do anything with the return value. Is that okay? This is kind of a weird question. Is it okay that there is a return value, but this thing doesn't use it? It doesn't save it anywhere. Is that okay?
I think so.
Technically it's okay, but it makes this line of code useless in a way. Yeah, it is okay because it's all right to get a value, and we'll see. It's okay to ask for a value and then don't do anything with it. So this line was okay. But when you get to it, you see that it really doesn't do anything. Okay, so now you get to this line. B is this guy. Get Y is going to return this 0, 0. But that 0, 0 is just going to, now you see, it's going to return 0, 0. But 0, 0 just went away and never got put anywhere. Okay, so, but it's okay. It's okay to ask for something and then not use it. Okay, so another way to put it, it's okay for a program to ask for a value and then not use it. Okay, so that one was okay, kind of useless, but okay. Okay, now let's try this one. Let's go through all of them. Okay, now we have to check a lot of things. We have a B thing, set Y. There it is. It's there. It's public, so we can call it. It takes a double parameter. We're giving it a double. So all that works. Okay, but set Y is void. What does that mean? What does it mean that a function is void?
If a function is void, it means it doesn't have a return statement.
So it doesn't give you an answer back. You call it and it doesn't give you an answer back in any way. Is that going to cause a problem down here in line 26? Is 26 okay or not okay?
26 looks okay.
Well,
Um,
what's going to be in W?
B,
B's an object.
or the set Y, the result that you get from the sending
But
set.
what is the result of set Y?
Oh, set Y is also a void. Yeah, no.
Yeah, so this thing does not return anything. So what's put in W?
Nothing.
Nothing. And that's actually a problem. If you create a variable, there needs to be something put in it. This line of code won't compile. See, didn't compile. Nothing cannot be converted to double. See, you want a double on the left, but the right-hand side's giving you void, which is a fancy way of saying nothing. You can't convert nothing to double, so that line doesn't work. The right-hand side is not the problem. Well, the right-hand side works, but the right-hand side doesn't give you something to put in the left-hand side. Now, if I deleted the left-hand side, what's left would be okay. See, that was okay. The right-hand side was okay, but the problem was this. Okay, so that line is not okay. Okay, so I'll comment out the ones that aren't okay. Again, you can tell that just by reading, and these problems you should be able to do them by reading the code, not by running the code, because everything you need is you can see it here. Okay, is there a B object? Yes, there's a B object. Can I call set Y on the B object? Well, is there a set Y in thing? Yes, there is. Does set Y take a double parameter? Yes, it does. Does set Y return a double that I can put into W? The answer is no. Set Y doesn't return a double that you can put in W. So that makes this one not okay. Okay. Next one. Okay. Let me copy that over to here. Okay. Is there a method A in the thing class? Now, this is the idea of a static method. Notice that I'm not using the name A or the name B. I'm using the name thing. That's one of the things we're going to talk about today. That was the last reading assignment of the course. If you go back over here, the last reading assignment was static variables, section 6.7. So that's we'll answer this problem, but if you haven't read this section, you won't know how to do this this part here that we're going to do. Okay, so this is what we're going to talk about today in a minute or so. Okay, so over here I got method A. Okay, there's a method A in the class, but method A does not have the word static in front of it. Okay, So this isn't going to work because this method has to be called on either A or B. Okay, but it's being called on the class, and those are what we call the static methods. So this is going to be not okay. All right. Now I can fix it by putting the word static here. If I fix it that way, whoops. Oh, I'm sorry. No, that's not going to work because that method can't access the X. Yeah, so I can't fix this. This one, the way I fix this is to go back down here and use either A or B. That's the better way to fix this. Method A is a method in the class. So I would fix this by putting the name A or B here. So that would be okay. I could fix it that way, or I could fix it by putting the name B there. Okay. But I can't leave the word. So the way it was, it had the word thing there. Okay, that would mean that this is a static method, but this is not a static method. It doesn't have the word static on after the word public. So this one's not okay. Okay. Now do this one. Okay. Okay. Method B. Yeah, there's a method B. See, so the A thing has a method B in it. Okay. Does method B take a parameter? No, method B doesn't want a parameter. See, method B just returns 3 times that number there. So method B uses that as its data. It doesn't want a parameter. So this one's got a parameter there. So the compiler is going to say, but method B doesn't. Okay. Required no arguments. See, method B required no arguments and was given an integer. Okay, so it's complaining about what's in here. Method B in class thing cannot be applied to given types. It required no arguments. It was given an integer. Okay, actual and formal arguments differ. So we use the word. This is an actual argument here, and this is the formal argument in there. So in their compiler error messages, the actual arguments are what are over here, and the formal arguments are what are in the definition. This is the definition, and this is the method call. So the actual arguments are in the method call. The formal arguments are in the method definition. Okay, so this one doesn't work. Okay, there should not be a parameter in method B. Okay, do the next one. Okay, whoops. I didn't copy. Oh, I copied too much. Let's see, we're doing this one. Okay, now let's think. We've got an A object. That's okay. Does A have a method B in it? There's a method B in there. Okay. Oh, no, I'm doing the same one again. I got lost about where I am. I'm doing the exact same one again. We're supposed to do this one here. Okay. All right. All right. Okay, I have a B object. Does B have a method A in it? Yes, there's a method A in there. Does method A need any parameters? No, method A doesn't need any parameters. Okay. What does method A return? Method A returns an int. But over here I have a thing. An int can't be put in a thing. Okay. See, an input needs to be put in an integer variable. This is a thing variable. An integer doesn't go into a thing variable. It won't take the int and somehow put it in the A object. A is a thing object. And it won't put the method A here. This method returns a number. And you might think, oh, it'll put that number inside that object because that object holds numbers, but that's not the way Java works. What this this is returning an integer, so it can only be put in an integer variable. Okay, so I would need something like an int I here. Okay, now, so let's check. This won't compile. Okay, incompatible types. Int cannot be converted to thing. See, A is a thing, but B returns an int, and you can't put an int in a thing. Even though the thing object holds ints, they don't get put inside there automatically. So this thing doesn't, you can't put an int in a thing variable. You can put an int in a thing object if you call the right method, but you can't put an int in a thing variable. So this should be something, this should be an int variable to make this work. If I do this, that'll work. I can take I could take the integer that this is returned and put it in an integer variable. Okay, but the way it was doesn't work. So that one is another one that doesn't work. Okay. Okay. And let's do one last one. Okay, now this one is a thing variable. And this is a thing variable. So it's asking, is it okay to put the thing from this object into that variable? And the answer is going to be yes. That's going to make A point to the same thing that B points at. So actually what will happen is I'm going to lose one of my thing objects. I've got two thing objects up here. I've got two thing names. I got the name A and the name B, and each one's the name of a thing object. When I get to here, I'll make A another name for the B object. So I'll lose this object here. The object that A was pointing at will go away, and I'll have A and B pointing at the same object. So this is okay. Now that I lose one of my objects, but the code will, you see, it did compile. Okay, if I start stepping through here. Okay. Okay, there's the line of code. A points to one object, B points to another object. I'm going to take the arrow in B, copy it to A. So there'll be two arrows pointing to this guy here. Now they look exactly alike. So when you do this, you just see one object disappearing. You don't, and you can't tell which one disappeared because there's the same numbers in them. Let's go do something. Let's put different numbers in them. Okay. Let's put one. Now, see, we have set X that lets us put numbers in here. So let's do this. Let's say A dot set X is 4 and B dot set X is 5. So now we can tell them apart. A will have 4 in it, B will have 5 in it for its X variable. Okay, let me go forward to there. Okay, put 4 in X and A. Okay, see now A's got 4 in it. The A thing has got 4 in it. The B thing has 5 in it, so I can tell which one is which. Now I'm going to copy the arrow from B into A. That's going to give me 2 arrows to the 5. The 4 one's going to go away. This arrow here is going to be replaced by a copy of that arrow. So that'll make this guy point to here. It'll make this guy point to here. So the two of them will point to the thing with 5 in it. Now the visualizer is going to move that guy up to the top. So when this one goes away, this one gets moved into its place. So it looks like this one changes, but really what's happening is this one just moves up there. See, the one that was down here just slid. The one that was up here is deleted because there's no arrow to it anymore. The one that was down here gets moved up here, and then you get this 2 arrows to it. Okay, but the line of code was okay. That line of code was okay, and now we can see what it did. It made the A object go away and made the A arrow point point at the thing that's the B object. So now I've got two names to that one object. Okay, all right. So remember, the class is here, and all this code here was supposed to be in a main method in a different class, though. The important thing is it has to be in a separate class. If I put this main method, let me just actually, oh. If I take this main method and make a copy of it up in here, a lot of those lines of code will compile. Not all of them, but a lot of them will. Okay, so for example, this one is okay now up there because we're in the thing class, so we can access the X method. Okay, this one's still wrong. This one's okay. This one's wrong for a different reason. This one's still okay. This one's still wrong. This one's still wrong. This one's still actually the only one that became right is this one here. Okay, that one becomes okay in that place. See, nothing went wrong. Okay, so this one is wrong here because the main method is not inside of the thing class. This one's okay here because this main method is inside the thing class, but that's not where it should be. It shouldn't be. Usually you don't put main methods in your classes. You put main methods in a program that tests the classes. So I could either call this one problem 11, or I could call this test thing, because it's a method that it's a class that tests the thing class. So that would be a good name for it also, test thing. Okay. Okay. All right. So that's all the, I'm going to change it back to problem 11, because that's a good name for it also. This class, problem 11, tests this stuff about thing. And this part here shouldn't really be there. Okay. So that, okay. What about other problems from the review? That's a good problem to do because it makes us step through and read. The key here is to read each line carefully. And you know, you have, and you can't read the line in isolation. Every one of these lines by itself looks like it's okay. There's no obvious errors in here, like forgetting a semicolon or not having a pair of parentheses. The only way you have to really look into the context up here. So you have to know whether the method needs a parameter or not. You have to know if the method takes that kind of parameter. You have to know what the method returns. So you have to go up here and look real carefully. What kind of parameter does each method take? What kind of return value does each method have? So the problems are asking you to really look carefully at the code up here and make sure that it works down here. Okay, what other question? Another one from the review problems.
How about 12?
12? Okay, do same thing. Let's copy it over into the Java visualizer. That'll make it easier to answer questions about it. Oops. Okay, now let's see. Let's just make sure. Let's see, what was the question here? Oh, there are several mistakes. Okay, so let's just go through the code and read through it. Now, the compiler will find the mistakes for us, and let's just explain them. Okay. Okay. We've got this class. It's got it holds one number, the current temperature. Then it's got a constructor. Okay. Oh, but look, there's a mistake already. Somebody like that. This is the mistake that the compiler just gave us first, but it's not the only mistake. So let's read from top to bottom. We have a class liquid. Okay. The liquid class holds a private integer current temperature. Then it's got a constructor. The constructor is supposed to give this thing a value. Okay, so you notice it doesn't have a value, so it gets its value from the constructor. The constructor says current temperature, that's this, equals CT. What's wrong?
There is no CT, right?
Yeah, there's no CT. What do you think CT stood for?
Current temperature.
Current temperature. So what's missing? How do I fix this?
I don't know. Maybe just give it a value.
Pardon me?
Integer. You can make a new integer or something, right?
Yeah, where I need a variable CT. Where does it really belong?
CT.
Now remember, what is the constructor's job? What is the constructor supposed to do?
To give the value for the current temperature, right?
Yeah, right. So where should this come from?
So should it be right under that?
No.
No.
Anybody have that? Where the constructor is supposed to give this guy his value. So it's trying to give him a value, but this thing isn't defined. Where's the right place to define this?
Within like the main method.
No.
Right.
Okay. The constructor is supposed to give this variable. The constructor is supposed to give this field a value. It's trying to do that. The constructor is trying to give that field this value. Think about the examples like over here. Where can this method get a value from?
Also from where it says set current temperature.
Pardon me?
So
What?
we could get it from.
What's this do? What is that? I just added, I added int CT. What does that do?
So now it's gonna search for NCT, right? Integer CT.
Well, what do we call this? This is a what?
Integer.
It's an integer, but it's, what are these guys here? What do we call these things? They're parameters to that's a parameter to this method. That's the input to this method. This is the input to this method. I gave this constructor an input value, and it puts that input value into the current temperature. So that fixes it. So I've now, the constructor takes a number that it will put in that field. Okay, so now this is okay. So that was the right. So the constructor, now the other possibilities, if I don't want to have that parameter there, would just be have the constructor set the temperature to 0, for example. So that, see, then I don't need a parameter. That would make the temperature automatically just 0. So I could fix this one two ways. I could either change that variable to a number, or if I want to keep that variable, I could say, oh, then I give this method a parameter so that it could take the value of that parameter and put it in the field. Okay, so that'll fix there's two ways to fix that. Now let's keep on reading. Let's see if there's any other mistakes. Get current temperature. See, now what this thing is supposed to be a get method. It's supposed to get that thing and return it to you. See, it's private, so you can't see inside of it. You can't see inside this method. So if you want to know what the current temperature is, you need to be able to get the current temperature. But there's two mistakes on this line. Line 10 has two mistakes. So let me see, what are the two mistakes in line 10?
Can I have the get attached to the current temperature? I don't think so, right?
Say again?
Could we have the get like attached to the current temperature in the statement, like public void get current? Shouldn't there be a space or?
No, no,
Okay.
that's the right name. You're going to get the current temperature.
Oh,
That's
just giving it the name. Okay, never mind.
yeah, it's got the name is correct, but there's two things wrong on this line. There's two mistakes on that line of code. The get current temperature name is fine. So the get current temperature name is okay. That's not the mistake.
It's the fact that it's a void, so it can't return anything.
Right. It's supposed to return. It's supposed to give you back. You're supposed to be getting the current temperature. So this needs to be int. That's one problem. So now get current temperature is going to return the current temperature. Oh, there's a problem down here. What should it be returning? If the method is get current temperature, what should it return?
Get current temperature, right?
Well, that's the name of the method. But what should the method return? It can't return get current temperature. That's the name of the method. Method doesn't return itself. Get current temperature should return what?
The current temperature.
Which is this field. So it should return that field. Now there's still another mistake in line 10. What else is wrong in line 10?
Instead of CT, it should be current temperature.
No,
Or
the get method. Why does it need an input? See, this method's job is to return that number there. See, get current temperature should return that number there. So what else is wrong on this line?
it doesn't need any parameters.
Right, it doesn't need a parameter. There shouldn't be a parameter here. It's a get method. It gets what's inside the object. So it doesn't need to be told any information. It's supposed to just get what's inside the object. Okay, so now this makes sense. This method returns an int, and the int it returns is the value of the current temperature in this object. Okay, so we fixed both those lines now. Okay, now let's look at the next line. Public void set current temperature. Now, set current temperature is a method that should change the current temperature. So it should set it. Okay, that makes sense. That's the new value for current temperature. So the idea would be that this guy is the new value to set the current temperature at. Okay, now what's wrong with this line down here? What does that line of code literally do? The way it's written, what does it literally do?
It just adds it. That's it, right?
Well, don't say adds it. Is it the moon? What is it? Use nouns. What does that line do?
That's the current temperature and current, the set current
Okay,
temperature.
so it takes the value in this variable and the value in this variable and adds them together, right? What does it do with that number?
Nothing.
Nothing. So so it's kind of weird. It doesn't do anything with that number. It doesn't. What usually what you, if you add two numbers together, what should you do with the result? If I add two numbers together, I get a new number. What in general, what can I do with that new number?
Return it.
You could return it. What else could you do with it? You could do three things with it. You could return it. You could what else?
Somebody wrote down make it a new integer.
You could, yeah, you could save it in a new variable. You could save it in a variable. You could return it. You could save it in a variable. What else could you do with it? You add two numbers together, you get a third number. What else could you do with the result? You could print it, for example. See, that would take, you could print it, though that would be a wrong thing to do here. Okay. All right. Now, should this method be adding these two numbers?
No, right?
No, because it wants to set the current temperature to this, not increase. See, that this would be like increased current temperature. See, this would increase the current temperature, sort of. But this says set current temperature. Does anybody see how this thing should have been written? Does anybody see what this was probably meant to be?
Probably the pluses should be equals, right?
Yeah, exactly. It was meant to be set temperature equal to that guy. There, now it's the right thing. Now it makes sense. This is the new temperature to set the current temperature at. So current temperature equals CT. Okay. All right. All right. So now, okay, now click on visualize. Okay, now we passed all the, it compiled, but we don't have a main method. So the visualizer complains because it doesn't have anything to run. So we fixed all the errors in here, but there's no main method. But that's not what the problem asked for. The problem didn't ask for you to create a main method. It just said, what are all the problems in that code? Okay, so the problems were that this guy doesn't have a value. It really should be a parameter. And you can fix this one two ways. You can either change that to a number like 0, or you could give this a parameter. So that constructor gets a parameter called CT. Okay. This one had a couple problems. If you're getting the current temperature, you shouldn't be a void method. You should be returning the current temperature. So this should be int here. A get method doesn't want a parameter. It's just supposed to return what's in here. And then this should have been returning this thing up here. Okay. And this one, we want to set the temperature to be this. That makes sense. This line makes perfect sense. You don't return anything, because when you're setting something, the job is to change this. So there's nothing to return. So set method doesn't have to return anything. The set method needs the new value for this. So this is correct. But then this didn't do the right thing here. This added the new value to the old value and then didn't do anything with that new value. It took the old value, added it to the new value, and didn't do anything with the result. The proper thing would be to take the new value and put it in the old value, in place of the old value. So the proper thing was to change that to an equal sign. Okay. All right. Okay. All right. So again, notice how you solve these problems by reading them very carefully. Real programming is all about reading things in very close detail. You have to really read these things in very, very, very much detail to be able to do these. Okay. All right. Let's go and let's do one last thing. I want to show you real quickly, just quickly explain the idea of what we mean by static. Okay. So there's this last reading on static variables and methods. Okay. Now, let me do an example in the Java visualizer. I've got an example here. I'm going to just copy it up there. Okay, I wrote this ahead of time. Okay. Notice that this class has got two fields. Remember, like this class had one field. They had one variable. This one's got two, called X and Y. But this one's got the word static in front of it, and this one doesn't. That means something very, very different. Static variables are not part of the objects. Static variables are part of what we call the class. This is really weird. Okay, now let me show you what I mean by that. If I go down here and I create a main method, actually, I should put the main method in a separate thing. Okay, so down here, I'll make this one, and I'll call a method here and say public test example. Okay. So this is where I'll put the main method. Okay. Now I'm going to create an example object. Okay. So I'm creating an example object. Okay. Now, okay. Since these things return int, I'll just return whatever the input is, that's the output. Wherever the input is, that's the output. What I really want to do is see what's different about these two things up here. Okay. Okay, there's my example object. Notice it's got a Y in it, no X. There's no X in there. See how the Java visualizer shows the X is separate. Okay. Now, suppose I create more than one object. So I'm going to call that X1, and I'm going to create an X2 object and an X3 object. So I'm going to create three objects. Notice I got three objects. I've got three Ys, one in each object, but I only have one X. That's the static one. Okay, and it's separate. So this picture is real important. This picture is really a key idea in this stuff. These static variables exist separate from the objects, and the visualizer shows them over here by themselves. Okay, so I have the static fields. Notice that they are called example.x. So you call them by the name of the class. So there's only one X by itself over here, even though I created three objects. And each object has its own Y. Okay. Now, what becomes interesting, one last thing, I have a static method here. The static method can see the static variable, but it can't see the instance variable. So I could return, like I can do here, a plus x. See, this method has this parameter, and it can see the static method can see the static variable, but it cannot see the y. For example, if I say plus y here, I'll get an error now. Non-static variable y cannot be referenced in a static method. They should say static method here, but they use the word context. The static method doesn't see the y because the static method is not part of the objects. It's not part of the objects. Okay. On the other hand, this method here, it can see the static thing and it can see the instance thing. Okay. So the non-static method can see its parameter, it can see the static thing, and it can see its instance thing. Okay. Okay. So what it works to is the F method. The F method sees this. The G method sees this and what's inside each one of these method objects here. So each one of these objects has its own G method. So another way to think about it is there's only one F method and it's shared by everything over here. But there's a G method in each one of these. The G method sees its Y and sees the X that it's shared with all the others. The G method in here sees its Y and sees the X that's shared. Okay, so it's a very strange concept, and it's not clear why it's there in the programming language. There's a good reason to say that these things shouldn't exist. Not all object-oriented programming languages have this idea of a static thing. So the idea of a static thing is not everyone agrees it should be in the programming language. Okay, there's a few object-oriented programming languages that don't have it. Okay, it's very tricky, and eventually you'll start learning how it gets used. And there's actually one school of thought says you should never use these. There is a lot of people who think you should never have static variables in your classes. Okay, so a lot of companies don't use them, and they would have a rule that you should not have a static method in any of our classes. So static fields and static methods are kind of controversial, and they are confusing and they're a little bit tricky to work with. So, but the key idea is that the static fields are not in the objects. They sit separate from the objects. So each object has its own copy of Y. All the objects share X. Okay. So remember, all objects have their own Y. All the objects share one X. If you have a regular method that doesn't have the word static in it, it can access its own Y and the shared X. That's okay. If you have a static method, it can't access any of the Y's because they are all in their objects, and the static methods don't have access to the objects. The static method only has access to the shared field. Okay, so every object shares X, every object has its own Y. The regular methods can access everything. They access their own Y and the shared X, and the static methods only access the shared static variable. Okay, well, we run out of time. That's the last thing. Okay. All right, so if you have questions about the review or if you have more questions about the homework, send me email or come to office hours, and I'll put these examples that we did today, I'll put them up on the course website later this afternoon. So I'll put these if you want to look at these review problems in this example here. Okay, so anybody got any last question? We've run out of time. Does anybody have any last question? We don't meet next week. Final exam week, you don't have any classes during final exam week. So on the day of the test, though, I'll be at my computer the whole day. If you want to send, just like when we had the exam, the final exam will be just like the other exams were. You'll get the exam in the morning. It'll be available in the morning. It'll be due in the evening, and I'll be around all day if anybody wants to ask questions. Like I'll be in office hours on that day. So yeah, I have office hours at 3:30 on Thursday. So I'll have an office hour that day also. But you can send me email anytime during the day. And if you want to come to the office hour during that day, you can do that. So the exam will be on the course website. There won't be a class on Tuesday, so there'll be nothing up here for Tuesday. But on Thursday, there'll be a reminder here about the exam, and the exam will be on Brightspace. So there'll be a reminder up here on Thursday for the exam, but the actual exam will be available on Brightspace. Okay, all right. Anybody have any other question? Okay, it was a good semester. It was a weird semester. Yeah, very, very, very strange way to be doing everything. Hopefully next year everything will be much, much better. So let's hope that next year things can be back to normal. Okay, so good
Thank you,
luck with.
Professor. It was a good class.
Oh, sure. Good luck on your final exams, and have a good summer also. Okay, so I'll go ahead and stop sharing and end here, and let me know if you have any more questions, or if you have, or come to office hours or send me email. Okay, bye.